Okay, guys, so this will be the last video over combined gas laws. So let's jump right in. Remember, our combined gas law is P1 V1 over T1 is equal to P2 V2 over T2. Now, we have to make sure our temperatures are always in Kelvin, so we'll take our Celsius and we'll add 273 to it. We need to make sure that our pressure units match on both sides and our volume units match on both sides. So our first example, a gas has a temperature of 14 degrees Celsius and a volume of 4.5 liters. If the temperature is raised to 29 degrees Celsius and the pressure is not changed, what is the new volume of the gas? Okay, so our first step is going to be write the formula. So P1 V1 over T1 is equal to P2 V2 over T2. Now, it says that the pressure is not changed in this question, so we're going to cancel out the pressure on both sides. So we're not going to even deal with pressure. So pretty much we have a Charles law problem. Now, our temperatures need to be in Kelvin, so 14 plus 273 is 287 Kelvin. In 29 degrees Celsius, convert that to Kelvin, you get 302. So we're going to plug in our numbers. So we get 4.5 over 287 is equal to V2 over 302. And we're going to cross multiply and divide. So we're going to cross multiply 302 times 4.5 and divide by 287. And we should get a volume. V2 is 4.735 liters. Okay. Number 2, second example. Okay, a sample of argon has a volume of 5 milliliters and the pressure is 0.92 ATMs. If the final temperature is 30 degrees Celsius, the final volume is 5.7 milliliters. And the final pressure is 800 millimeters of mercury. What was the initial temperature? Of argon. Okay, so we're going to write our formula first. So P1 V1 over T1 is equal to P2 V2 over T2. Now, in this question, we have to match up our units for pressure because we have atmospheres and we have millimeters of mercury. So recall that there's 760 millimeters of mercury to 800 millimeter to 1 atmosphere. Sorry. So we're going to say 800 millimeters of mercury. This is going back to our first lesson over 1. There's 760 millimeters of mercury to 1 ATM. So when I do that conversion, 800 divided by 760, I get that this is 1.0526 ATMs. Okay, now plugging in my numbers. I can't do that yet because we need to find this temperature in Kelvin. So 30 plus 273 should come out to be 303. And we're looking for the initial temperature. Okay, so P1 is 0.92. V1 is 5 milliliters. And T1 is what we're looking for, the initial temperature. It says the final volume is 5.7. The final pressure is 1.0526. So we'll put a 5.7. I'm running out of room. Over 303. So what we're going to do is cross multiply 303 times 0.92 times 5. And we're going to divide by 1.0526, and we're going to divide it by 5.7. Okay, so your initial temperature should be 232.307, and that's Kelvin. Temperature is always in Kelvin. So that gives you an example problem to where we had to convert. Okay, last example problem for combined gas law. And we'll be done with that. Okay, so last example. If I have 2.3 liters of gas at a temperature of 67 C and a pressure of 88.89 atmospheres, what will be the pressure of the gas if I raise the temperature to 94 degrees Celsius and decrease the volume to 12 liters. Okay, so we're going to start off by writing our formula. P1 V1 over T1 is equal to P2 V2 over T2. Okay, so we need to do our temperature conversion. So 67 degrees Celsius plus 273. This goes to 340 Kelvin. And 94 degrees Celsius plus 273 gives you 367 Kelvin. Liters match up with liters, ATMs, and we're looking for the final pressure. So initial pressure is going to be 88.89 atmospheres. Your volume's 2.3. T1's 340. P2. V2 is 12 liters. And your final temperature is going to be 367 Kelvin. We're going to cross multiply 367 times 88.89 times 2.3 divided by 340 and divide that by 12. So I got 18.390 ATMs. Just double check that real quick. Okay, yeah, so that's what we got. Now, so that's combined gas law. If you have any questions on this, feel free to reach out. And hopefully this was an easy lesson for you. Have a good one. Bye.